So what you're going to have to do, right now this is in rectangular form. And we want to convert it into polar form. Okay, so there's two things that you got to find. First, you got to find the radius, so you got to find r. So you have to get the modulus, I should say. Okay, so that's easy. All right, so that's just 3 squared plus 4 squared. And the modulus for this guy is going to be the same thing because the negative doesn't affect the modulus. Yeah.
This was in the bathroom.
Oh, thanks. Gee, you guys didn't, you failed me again.
What?
No heads up.
Oh, sorry. Oh.
No clearing of the throat. No intruder. Stranger danger. That could have been an assassin. It could have been the IRS looking for me too. Or the FBI.
Have you been committing tax evasion?
A little bit here and there, but jeez, gosh.
He's a math guy. All math guys do math.
Yeah, go ahead. Boy.
But some girl stole your pass from me?
No, that's okay.
Oh, she brought it back.
Yeah.
I was like,
Yeah, I don't even hear these people come in. I need like one of those little laser detectors. That's what I need. All right.
I was like, what the heck? I like walked out and was gone. I was like,
It was one of the security gals. That's okay. So this doesn't matter because when you square it, it's still the same thing. So both of these have the same modulus. Okay, now the part that you got to do a little bit of thinking on is the argument. So the argument's the angle. All right, so to get the argument, I would graph, so that you know what quadrant you're dealing with. Okay, so if I was to graph this guy, let's see, 3, 4. So 1, 2, 3. 1, 2, 3, 4. This is my real number axis, and this is my imaginary numbers. And that point is right here. And now for this one, 3, negative 4. That's going to be right here. Okay, now both of these you can do on your calculator, and here's how you know why. We're going to be using the inverse tangent function. Okay, so when you use the inverse tangent function, your calculator is going to give you answers that are either up here, if it's positive, or down here if it gives you a negative number. So you don't have to do any special thinking when you're doing these, because the calculator is going to give you the answer that you're looking for. All right? It's when the angle that you're looking for is over here or here that you got to take what the calculator gives you and then do a little bit of figuring to get where the angles are. But we don't have to worry about it because it's right there. It's in the first and the fourth, and your calculator gives you the answers for the first and the fourth. Okay? All right, so to get the first one, you're doing the arc tangent. So to get the argument, you're going to do the inverse, or you hear me say the word arc, it's the same thing. And it's going to be the B over A. Okay, now just the reason why is the angle that we're looking for, okay, is this angle right here. And this is the opposite side, which is the imaginary part. And this is the adjacent side, which is the real part. And the inverse tangent is equal to the opposite over the adjacent leg. So that's why it's B over A. So all you got to do now is you just type this in. Make sure that let's see, we're going to be in degrees. Okay, so let's see, it's going to be 4 over 3. So that's what goes in. Okay, I'm going to do it on Desmos here. Okay, and I'm going to go inverse tangent. So I open up my keyboard. Functions, and there's my inverse tangent, tan negative 1, and I said it was 4 divided by 3. Okay. Enter, and there's my angle. Now I think that's in radians, so I'm going to switch it over here to degrees. So that's 53.13 degrees. Okay, that's my argument. So I think when we're doing this, we'll go out to 2 decimal places. So I'll just say 53.13. So this is equal to 53.13. Okay, anybody need help getting that on their phone or their calculator? So now that you got these two things, you can write your equation. There's your argument. There's your modulus. Okay, so in polar form, polar form is R equals, R times the cosine of the angle plus I times the sine of the angle. So this is going to be 5 cosine 53.13 plus I sine 53.13. And there's your solution. So that's polar form. So they're the same place, exact same angle, or exact same point. It's just different ways of describing the location, that's all. All right, anything I did there you're not quite sure of? All right, now when you do this one, okay, my B is going to be negative and my A is positive. because that's 3 and that's negative 4. So to get my argument, it's going to be negative 4 divided by 3. Okay, now when you do that, it's going to give you a negative angle. All right, so we go back to our Desmos. And all I got to do is change this thing to a negative 4. And so now that's negative 53 degrees. That is not your solution. Your angle has to be between 0 and 360. Okay, so you gotta, so when I do this, I get negative 5313. All right, so the angle that I want starts here and goes this way. Right, so that's going to be 360, take away what we got on our, okay, so 60, take away 53, 13, and the angle that we're going to use for our argument is 306.5 or 87. So this argument has to be between 0 and positive 360 degrees. That's why we had to change it. Okay, so we got 5. Okay, and there it is. Okay, so let me show you what happens if it's not in one of those quadrants. What happens when you do it on your calculator? Okay, so I'll just call this C. Okay, so let's say that it was negative 3 plus 4i. Okay, so its modulus is still 5. But when we plot it, 1, 2, 3, 1, 2, 3, 4, it's located right there. Okay, and the angle we want is that. Negative 3 plus 4i should be 3 to the left and 4 up. Did I mess that up? Okay. So it's just, what do you, because your calculator gives, I just want to go over what do you do to get your answer here. Okay. So this is the angle that we're looking for. This is known as, that's the argument. And then the other situation is, well, what if it's in the, that would be the second quadrant. What would you do if it was in the third quadrant? So it would look like this. Okay, same modulus. 1, 2, 3, 1, 2, 3, 4. And now our argument for that would be that angle. Okay? So those angles don't show up on your calculator. All right, so if I did this one on my calculator, it would be the tangent, the inverse tangent of B over A. So B is 4 and A is -3. Okay, so on the calculator, or if you do that on your phone, it doesn't matter where you put the negative. You can put it in front, you can put it behind, on the top, on the bottom. Wait, what is going on? Okay, let me do it on Desmos. I'm getting a ginormous calculator. Okay. So it wouldn't matter how I type this in. Where the negative is, doesn't matter. It's the same thing. Whether I put it on the top, the bottom, in front, it's all the same. Okay? So what you got to do on this one, okay, if you did this on your calculator, you'd get the -53 again. And then you got to use that to get the angle that you're looking for. All right, so let's zoom in here if we can. So the angle that it gives you is down here. Okay. It's this angle. That's the -53.14. So remember vertical angles in geometry, they're the same. So this angle right here is 53.14 or 53.13. And now if you subtract that from 180, you got your argument. So I'm going to go 180 take away 53.13. 180 minus 53.13. And that angle's 126. So that's your argument. Yes. Mm-hmm. All right. Crowley. Yes. Spencer West. You betcha. Okay. Bye-bye. Miss Corrales, need to see you, Spencer. Okay. All right. So when you do this one, you would type in tangent. And this would be -4 over -3, which is the same as positive 4 over 3. And we know that that's 53/13. So that's, again, now that angle is up here. This angle right there is 53/13, which makes this angle 53/13. And now you'd add it to 180. And the angle on this case would be 2, 3, 3, 1, 3. That would be your argument. Okay? All right, any questions on that part, guys? You understand why you have to? You just got to think where it is, and then once you get the angle from your calculator, you might have to do a little bit of work to it. Okay. All right, now this one, you're doing the same thing. All you're doing is you're changing it to radians instead of degrees. Nothing's changed. Okay, all right, so let's figure out what the modulus is. Two squared plus 5 squared. And we just leave it as root 29. You don't write it as a decimal. All right, and then we'll graph it. So 1, 2, 1, 2, 3, 4, 5. Okay, and so to get this angle, okay, now make sure your calculator is in rads when you do this. So if I'm doing it on Desmos, I go up to the monkey wrench here and I change it to rads. All right, and it's 2 and 5. 2. And the instructions say round it to the nearest thousandth. So tenths, hundredths, thousandths. That's 3 decimal places. So the 2 tells me leave the 0 alone. Ready? So that's going to be, whoops, 1.190. Okay, and that's radians. All right, and then in, let's see, we're going to have root 29, cosine Correct. Olivia? Gotcha. Which Olivia? I've got two Olivias. I have three Olivias. Which? Gotcha. All right. Bye-bye. Miss Beaver? Okay. All right. Next one. Modulus. All right, sketch it. Okay, -6, 1. 1, 2, 3, 4, 5, 6, 1. Okay. Okay, so this is -6 plus I. Okay, so the angle that you're looking for to get the argument is this. Right? Right, so B's 1 and A's -6. Relax. Chloe? Okay, alrighty. Thank you. Chloe, you're heading home? Let's see who's next. Player 2 eliminated. Okay. Now we're going to do this in radians, guys. So when we get the answer, it's going to give us the answer that it's going to give us a negative tangent. All right. So on our calculator here, tangent, and this is 1, 6, and it's negative. Okay, and I want to make sure that I'm in radians. Okay, so let's see. All right, so the angle that came out of my calculator is negative 0.1. Oh, bless it. Rolex. Yeah, just send her out. Okay, anybody else? It's like the fourth person.
Please, please.
Okay, thanks. Bye-bye. Okay, so the angle that gave you is this one in green here. Okay, so that's negative 0.165. Okay, so this one right here is 0.165. Okay, so if that thing was in degrees, it would be easy. If it was in degrees, we'd go 180, take away whatever the degree was. But you're not working in degrees anymore. So normally this would be 180 minus whatever the angle was that you got from your calculator. But now it's in radians, so instead of using 180, you use pi. So this is going to be pi take away that angle. Now, to be accurate, use the pi key on your calculator. Okay, I imagine there's a pi key on your phone somewhere. Okay, I'm going to do it on Desmos. So to get pi on Desmos, just type in pi minus, and it's 0.165. And there's my answer. See, 29765. So this 5 tells me to round that 6 to a 7. So 2.977. 2.977. Okay, so then my answer is there it is. Okay. All right. So let's see, close this.